Welcome to Eytm Technologies. Welcome to Eytm Technologies. In the present video, we are going to see how we can upload any program. How we can interface our trainer board, the Eytm dip kit. We are going to learn in today's video. You can see here, this is the trainer board. This is called Arduino Nano. You can see there is a connector, and you can also see several pins available here. So on this Arduino Nano, basically you are going to have total of 14 digital pins. 14 digital pins, that is from 0 to 13. And similarly, you also have what you call analog input pins, which are mentioned as A0, A1, A2, A3, etc. up to A7. So these are called analog input pins, and the other ones are called digital pins. They are marked here, you can see, and there are black connectors on this side and that side, which are also marked with the same namings, and you can put a wire there to interface or to connect with any device. So this is about Arduino Nano, and on this board you have several peripherals available. So those peripherals are basically an LCD, a liquid crystal display. You can see here, this is the 16:2 I2C based liquid crystal display. And similarly, you have another one, which is the servo motor. So this is called servo motor, which is SG90 Tower Pro, which is the 0 to 180 degree pulse width modulation controlled servo motor. And there is another shaft which is shown over here, and this shaft is basically a PMDC motor, permanent magnet DC motor, direct current motor. This can be operated up to 9 volts, but we are running at 5 volts. So already connections are made from the back side, and this motor is basically driven by a motor driver IC. You can see the motor driver IC. It is basically L293D motor driver. So it can actually control 2 channels, but we are using only 1 channel. So even this you can connect with some wires. The biasing is required, but it's already done on the back side of the board. Well, if you want to change the pins, you can actually remove the jumper clips. Here you can see the jumper clip. If you remove the clip, you can actually connect a wire. So it's up to you to decide. So here what we have done is, we have connected the motor driver pins already to pin 12 and pin 13. You can see here pin 12 and pin 13 are written over there. So to Arduino's pin 12 and pin 13, we have already connected these things from the back side. And if you want to use a different pin, just remove this clip, and from a different pin to this connection, you can actually join a jumper wire. And you can connect it on a desired pin. And another pin is there, which is motor 6, which is mentioned here, PWM 6. So basically it's the pulse width modulation to control the duty cycle of this particular one, and that can be done with the help of the enable pin on the motor driver IC. And this is the barrel jack connector. Here we will be feeding 5 volts. So we have supplied you the adapter, only 5 volts you have to give, and if you give any excess voltage, it is going to damage the total board. So please remember, you should give only 5 volts and you should not exceed it. Whatever adapter is supplied to you, that is 5 volt, 2 ampere rated, only use that with the help of the barrel jack. Don't use any other. And this is the light sensor. Here you can check the intensity of light, or more precisely darkness in the room. How much dark the room is. If it is fully bright, you can read a low value, and if it is fully dark, you see a higher value. So it is basically a darkness measuring sensor, which is the light dependent resistor, which is biased with a 100 kilo ohm resistance. And you also have other peripherals like push buttons. You can actually connect 4 push buttons. You can operate the LCD with the help of these push buttons, and those buttons are actually connected with switch 1, switch 2, switch 3, switch 4. 4 pins are there. So these pins you can use a female DuPont connector, female Berge connector, and you can join it to any desired pin on the Arduino Nano. So if you want, you can bias it. These biasing connections are not done on the board internally. You have to do it from outside. And these pins are actually active high. Active high means whenever you press this push button, you get on the switch pin a high signal. What I mean is, if I press this button, I get a high signal of 5 volts on the switch 1. Similarly, if I have the S2, when I press this button on S2 pin, I will get high voltage of 5. And as long as I don't press these buttons, all these buttons will have a 0 state. So the voltage at these pins will be 0 unless and until you press the button. So when you press the button and simultaneously if there is a wire connected to any pin, you can detect a high signal there. So this is about pin connections. And similarly, LED 1, 2, 3, 4, total 4 LEDs are there, red LEDs, along with a buzzer. So this buzzer is here. Actually it is covered with paper to avoid dust, but if you want more sound you can remove this paper, but I suggest you to keep it to avoid any entry of dust. So sound will be quite enough to hear. Okay, so this is about these things. And there is another temperature sensor. You can see here thermistor. So you can measure the temperature of the room with the help of this thermistor. So it is also an analog pin which you can get it from a pin A1. So here already another clip is there. You can see it is written as therm. So on this side it is therm, on other side it is A1. It means if you want to use the thermistor on this board, you don't have to connect any wire. You can just read it from the A1 pin of the Arduino. But if you want to use a different pin, let us say I don't want to use A1, I want to use A5, then remove the clip. Remove the clip, use a DuPont wire, female wire. Just you plug it on this side where therm is written, and from there you join it to any desired pin like some A5, A6, etc. Any of the analog pin, whichever you like, you can join it there. This is about thermistor. Similarly, the LDR, the light sensor which we have seen, is also available here, which is mentioned as LDR. Here also there is a clip, and by default it is connected to A6. So if you want to use a different pin, then definitely you can remove the clip and use the other. Otherwise, by default it comes at A6 pin, and by default this thermistor comes on A1. And there is one more, which is the soil moisture sensor. A0 is written over there. So just you plug it here. We will be providing you the soil moisture sensors clip. So you can just put it here. There is no polarity for that. You can connect it either way. So just connect it here. You can measure the soil moisture from pin A0. So this is by default A0. You cannot change it because we have to give 2 pins. So we have fixed it. This is about soil moisture. And if you want to control a water pump, we have provided you a submersible pump, a mini submersible water pump. There is a connector here which you can plug it over there. Remember, this is a foolproof connection. It goes only in one direction. Even if you connect it in the other way, motor is going to work in a similar manner. So this is about water pump. And if you want to use any I2C devices other than the LCD, you can just plug it in here. This is the I2C bus. Next to I2C bus, you have an RGB LED. So this RGB LED, it has red, green and blue, all the 3 LEDs in the same 5mm package. You can just drive it with the help of the 3 pins connected over there, which are D9, D10 and D11. So Arduino's D9, D10 and D11 are reserved for this because these are 3 pins we have not given any choice. Why? Because it is a pulse width modulation control. So you don't have much options left. That's why we have fixed the pins to 9, 10 and 11, as Arduino supports only 9, 10 and 11 as well as 3, 5 and 6 pins. Only these pins, 6 pins, are going to support the pulse width modulation. That's why we have dedicated this. Anyway, our third pin is connected to this motor pump. That is, this water pump also you can control the speed. So we have dedicated the third pin for it. So there is no option left for us. That's why we have given directly from 10, 11 and 9 pins to the RGB LED. So this is the total description of the board. Thank you.